In 1978, Intel reported some strange errors popping up in their 16 kilobit dynamic random access memory, or DRAM. Ones would spontaneously flip to zeros with no apparent cause. The problem turned out to be the ceramic packaging the chip was encased in. With the demand for semiconductor packaging skyrocketing in the 1970s, a new manufacturing plant was constructed on the Green River in Colorado. Unfortunately, this site happened to be just downstream of an old uranium mill. Radioactive atoms made their way into the river and then into the ceramic packaging for Intel's microchips. Intel scientists investigating the problem found that even trace amounts of uranium and thorium in the ceramic were sufficient to cause problems. In their DRAM, memory was stored as the presence or absence of electrons in a semiconductor well. The alpha particles emitted by uranium and thorium were energetic and ionizing enough to create electron-hole pairs in the silicon. If an alpha particle struck in just the right place, it could create a large number of free charge carriers, causing electrons to accumulate in the well, flipping a 1 to a 0. This is known as a single event upset, a type of soft error. The error is soft because the device hasn't been damaged. The bit has changed, but you could erase it and rewrite it with no problems. Investigators exposed the chips to alpha emitters with different levels of activity, and just as you'd expect, they found the number of bit flips directly correlated with the number of alpha particles the chip had been exposed to. The reason this problem was identified in the 1970s was because chip components had been miniaturized to the point where a single alpha particle could produce enough charge to flip a bit. Immediately, these findings attracted a lot of attention. Before the paper was published, it was widely circulated in the industry, and as a result, chip manufacturers were a lot more careful to avoid radioactive materials when producing their microchips and packaging.